Okay, here we go. Who is influential on Twitter? Okay, obviously we're all thinking of someone who lives sort of nearby. But this is a question that's actually been studied a lot in the sciences, and there's a great review article of all the different ways in which we have tried to classify influence on social media. And today I want to talk about those different ways that we measure social influence, but I also want to look at scientists in particular and see how good a job we're doing at being influential, at moving people's opinions online. This particular review essay is fantastic. It's very detailed. You're not expected to read that. Just look at how amazing it is that there's so many people that have worked on this. And they try to classify all the different ways that we have looked at influence online. One of the ways that you can do this is just with activity. If you tweet a lot, you're eventually going to have more followers. You're eventually going to have people quoting what you say. You're going to have people responding to you and so on. And so the very first thing that you want to measure is how much you actually participating in a given platform. And a lot of the measures of influence, they rely on that as part of their calculus. Another thing that you can look at is responses. And that kind of gets a little closer to influence, doesn't it? Because now it's just not saying words to an empty theater, but actually hearing the words back. And there's ways that you can look at responses in social media that allow us to know if people are, for example, passing along what you say, or if they're replying to you, or if their words are maybe changing as a consequence of what you've said. The last kind of thing that we look at for influence is your network. Okay, so how many followers do you have? Are you at the center of the network, or are you at the edge of the network? Now, I'm a network scientist, and I love these kinds of measures, but I get really frustrated with these measures because just because you're at the center of a network doesn't mean that you're influential. You could be saying things that are completely banal and to millions of people and not changing their lives at all, not changing how they would have responded. And it's really important, I think, to think of the counterfactual. What would that person have been doing if you hadn't tweeted? What would that person be doing if you hadn't posted something on Facebook? And that's where a lot of these measures, they kind of fall down because they're just measuring quantity of stuff online. And in fact, there's lots of different ways that you can look at specifically Twitter where there's things that we do that fall into these categories. So you have tweets, that's activity. You have replies. Okay, so you can reply to someone's tweet. That's one way of responding. You can retweet what somebody said. So you pass along somebody's message to your own followers. You can favorite what they said, say that you liked it. You can mention somebody in a tweet. So that's another kind of response. And then you also have these network measures, which are based on the network of followers and followees. So there's lots of different ways that you can count influence. But when you start talking about counting influence, it reminds me of an old, ancient university proverb. Academic deans can't read, but they sure can count. So it seems like the literature has actually been focusing more on what a dean would focus on. It's like, I may not be able to read all these articles, but I can sure count them on your CV. And that's not to say that the academic deans are doing the wrong thing. They're very busy people. Ideally, we'd like to be able to read all the tweets to see what happened to them, see whether or not people changed in response to them, but we don't have time to do that because there are literally trillions of these messages going on online. And so the reason why I think the literature has focused more on counting, more on quantity than on quality, is because of this problem that we're deluged with information. And so all of the focus, it's been on counting activity, counting responses. It's been on counting where you sit in your network. And so what I want to do today is I'm going to talk about potentially a different way of counting not quantity, but counting quality. And the way you might think about doing this at a massive scale is to think about how could you tell whether or not a tweet was a quality tweet? Well, one way that you could do that is by seeing how much information is in the tweet. And so just to give you an idea of how you would measure information, consider this poor girl who just got socks for Christmas from Aunt Susie. Now, Aunt Susie gives her socks every single year. Every single year she gets socks. Okay, now, this Christmas, she opens her present and there are socks again. There wasn't much information about Aunt Susie in that package because she does that all the time. But now suppose Aunt Susie does this instead. Gets you a brand new bicycle. You've never done that before. Now suddenly your ideas about Aunt Susie are changed because she's done something that you've never seen before. And so this goes to a very elemental kind of way of quantifying the quality of a tweet. And that is that we can quantify the information in a given tweet by how likely it is that that tweet would have occurred. So you're going to have a very low probability on that bicycle coming from Santa Claus, and as a consequence, when that happens, we get a lot more information about the world. And from information theory, the way that we have posited that you can compare pieces of information to one another is that you're basically taking the inverse of the probability. So the less probable something is, the more it's going to contribute to information. And specifically, the negative of the log of the probability is what we use to sum across different pieces of information in order to get total information in a message. Now, I like to do this on Twitter, but what that means now is I've got to be able to figure out what is the probability of a tweet. Now, there's lots of different ways you could do this. I'm going to do a dumb thing. I'm going to do the dumbest thing because it's the most transparent and because people haven't even really started to think about the quality of tweets in this way. I'm just going to take all the words on Twitter that have occurred in the last 24 hours. I'm going to focus just on responses because the idea is I want to measure how much one tweet provoked responses in other people. Just like Aunt Susie's present provoked a response, thanks for the socks, or wow, a bicycle. I want to be able to quantify those responses. So we're going to look at all the words amongst all the responders for a 24-hour period. And then in the next minute, what we're going to do is we're going to classify how likely it is that that tweet would have been drawn randomly from the set of all words on Twitter. And specifically, the way we can do this is through a multinomial distribution. We're just going to assume that those words are independent. We're going to assume a tweet is a bag of words, lots of problems with that assumption, but we're going to start simple. If you want to change the P in this, that's great, but this is a good place to start because there will be some information in that tweet based on the kinds of words that are used. Okay, so think, for example, about the difference between calling something an inheritance tax or a death tax. You would expect the word inheritance and the word death to have some information because those are words that don't come up a lot. They also come up in different contexts, but the more you see those words, the more likely it is that there's this conversation about the estate tax, for example. So we're going to do that. We're going to do that on about 25 million tweets in July of 2016. I intend to eventually expand this analysis to all of 2016. As a political scientist, I'm very interested in the year 2016. You might guess why. And so let's look at the data and see what it looks like. This is the number of retweets, replies, and quotes. And so along the x-axis, we're counting up the responses per tweet. So each tweet gets a certain number of responses. And so you'll see, for example, that most tweets I have just one response per tweet. And none of the zeros are actually shown on this. So this is just among those that got at least one response. Almost all of them, so that 1e to the 0.6, that's 1 million, right? Almost all of them get like one response. But then you have this long tail. These are log axes. And so normally this would just look like a thing like this, an exponential curve. But here what this graph allows us to do is look at the tails. And you can see that there's this exponential relationship that most tweets don't get any responses at all, but some get a whole bunch of responses. The other thing you should be able to see about this is that you get way more retweets than you get replies or quotes. It's easy to hit the retweet button. It takes a little more cognition, a little more effort for you to actually type a reply or to quote someone and to type your own message about what you think about what it is that they've said. Now, oh my, okay, so there's no information on this graph about information. So you're just going to have to imagine it, and I'm hoping my other slides don't look like this, but that's okay. As it turns out, this measure of information is log-normally distributed, and if you were to see something on this graph, it would look basically like a bell curve centered in the middle. And again, we have the x-axis is logged. So what this is telling us is that most tweets don't have much information, but there's this long tail of tweets that do have information. We start to look for things like you would expect to see. Tweets that are longer have more information in them. Good, check. There's a diurnal pattern in information, and this is because there are different people tweeting about different things at different times of the day and night. There are all different kinds of people tweeting, so sometimes people are tweeting in the United States, sometimes people are tweeting in India, right? And that's, the rates of tweets are going to depend on where the Earth is with respect to those individuals. At first I thought this differences over time in information scores might be driven by countries, but you can see here these are different countries and their average information score, and there are some differences. So between English and Japanese on the far left of this, you can see an increase from about 64 to 66, but it's not as big as you would think, and compared to the time cycles, it doesn't look like language would explain all the difference in the information score over time. Okay, so what do we do with this information score? Let's talk about you and me and compare us to the rest of the world. Now, I can't really go and look up all of the scientists on Twitter, but fortunately, these folks have done it for me. This is a lovely paper published in PLOS One, where they've actually used lists of scientists that other people have made on Twitter to go and find all the scientists. It's really ingenious. It's like the computer didn't do it. They just had the computer scrape what a bunch of humans had already done. And so what you can do then is you can use this list to try to compare scientists, people who are called scientists on Twitter, to people who aren't. But first you have to solve a certain problem, which is that the way we identified these scientists in the first place was that they were on lists. And so as a result, you get a very different distribution between the scientists and the non-scientists. Most people on Twitter are not listed by other people for anything. You're not on a list of biologists or crazy people or whatever, right? But scientists, in this process where we discovered who the scientists are using the lists, most scientists are on about 10 lists. And so you see these blue dots. There's kind of this average scientist that's sort of in the middle. And then you have scientists like Neil deGrasse Tyson who end up on tens of thousands of lists. What you want to do if you're going to compare the non-scientists to the scientists is you want to correct for this problem. And so what I'm going to do is I'm going to match the scientists to a sample of non-scientists that have exactly the same distribution of these lists. Okay, so if there's one person that was listed 10 times, and then there's going to be in the scientist group, we're going to draw at random a person from the population who's listed 10 times who's not on the scientist list. And then we're going to start to do these comparisons. And none of these are going to come out on the graphs. So what I'm going to do is I'm going to just explain to you. What we typically find is that the scientists, when we do this comparison, are like the middle class. Okay, so when it comes to user favorites, for example, they get more user favorites than the long tail of regular people, but they also get less than the long tail of regular people. So there's some people that are getting lots of favorites, some people are getting very, very few favorites. Scientists are sort of in the middle. We also see the number of followers. Okay, scientists tend to be in the middle on the number of followers. They tend to be in the middle on the number of friends, as the people that they follow on Twitter. Where they are not like the regular folks is that they tend not to tweet as much. Okay, so we're busy. And tweeting isn't necessarily the first thing we do. You can imagine that the long tail of everyone else on Twitter is driven in part by people whose whole career is to be on Twitter. Again, local people living in Washington not accepted. So now let's take a look at what that means. What that means is that because scientists tweet less, we get less retweets per person, we get fewer replies per person, and we get fewer quotes per person. Okay, so that's not surprising. We have lower activity, so there's going to be fewer responses. But what we can do is we can look at the information scores. The information scores again show you this problem of us not tweeting enough. In fact, what it looks like is happening, because we tweet less, we actually get less information overall into the Twitter sphere. But whenever you look at the average amount of information per scientist, per tweet, what we find is that scientists actually are able to do even better in terms of these information scores than non-scientists. So the moral of the story is that we don't tweet as much as other people, but when we tweet with a higher amount of information. Now, why is this important? This is important because it has an impact on the world. We did a study where we showed that messages on Facebook got people to vote in the real world. In fact, it looks like in 2010, those messages got about 1/3 people to vote. And so ideally what we'd like to do is we'd like to see whether or not this information score, the quality of these tweets is also driving some kind of real world behavior. I don't have that yet, but I do have what should be an intermediary thing that we would expect to see, which is that the quality of tweets ought to be driving future responses. So we can see this visually, first of all, by showing that as the information score of a tweet goes up, it increases the likelihood that you're going to get retweets tomorrow, it increases the likelihood you're going to get replies tomorrow, and it increases the likelihood that you're going to get quotes tomorrow. Now that's not surprising that the raw data shows this, because people who tweet more are also on average going to get more responses. And so what you need to do is you need to control for individual variation. And also remember that diurnal thing I was showing you about the information score, which is, Twitter is heavily diurnal for reasons I explained. You also want to be able to control for time. And when we do this, whenever we have a fixed effects model where we're measuring this within subject effect, we're able to find that increasing the information in your tweet actually increases the number of retweets, the number of replies, and the number of quotes. So let me just conclude by saying that what we really need to do as we're moving forward and thinking about these social media measures is I think we need to move out of the stage of where we're counting things, out of the stage of the quantity of replies, and try to think of creative ways where at scale we can measure the quality of them. It's only then that we're going to be able to start to think about how one scientist's actions might actually be able to change other people's opinions, and perhaps even things in the real world that we care about, like policy and people's roles and actions within the world. Thank you very much.